done. Sorry. Okay, sorry, a bit more. All right. Now, if there is no more question, we're going to finish the last reaction. I promise you everything is easy this week, so this reaction is also very easy. Here is the last guy, right? Last. For some reason, my pen is not working. Now, why is my pen not working? For some reason, my pen is not working. Oh, now I have a technical problem. There you go. Okay, got it. Okay. So this last arrow, remember that this guy is acid, right? This guy is acid. We call it carboxylic acid. But the point is, this is an acid. And an acid will always have a H plus, right? An acid means it releases a H plus, right? And therefore, I now introduce you the H plus part of this guy. This is your H plus, and this is therefore your O.
Is that vinegar?
That guy is not vinegar. It's just an example. A vinegar is more complicated than this guy. But this is just me saying sugar to wine, wine to vinegar as an example.
Wait,
This
how
is
about the
not
other
a
one?
vinegar.
The other one, the CCCOH.
The
Is
wine, right? The wine is just an example.
Oh, it's an example.
Example. Sorry, I didn't mention the word example. Apologies. Okay, was confusing. For example. Because in questions, they will do that, sugar become wine or wine become vinegar. Then you may not know, what is this guy talking about? Well, vinegar is just carboxylic acid, one of them. Wine is just grape juice, which contains sugar with some alcohol. Wine, wine acid. Okay, back to carboxylic acid. I have now introduced the fact that this guy will be H plus and therefore this guy will be minus. This is something that happens aqueous. This is an acid. Okay. Once I have done that, acid plus base, right? Acid plus base. Oh, sorry. Better put alkali. Sorry. Alkali. And the most famous example of alkali is, for example, Eg NaOH, which you will recognize as Na plus and OH minus, right? So my acid plus my alkali will become something, right? Okay, let's revise this. Matthew, acid plus alkali becomes
salt
and
water.
good. The water part is easy, right? The water part is easy. Here's my OH there. That's obvious. Here's my H plus. Okay, that's just obvious, and therefore my water is HOH. Ta-da, H2. Done. How about the salt? Now, who is the brave soul that can, that is courageous to try? What will be the salt? Anybody? Volunteer, please. Anu, volunteer.
I'm guessing sodium and sodium.
And here's your sodium. Here's your sodium, right? And who? Just look at the picture. And who?
The vinegar thing, the carboxylic.
The remaining of the guy without the H, right?
Yeah.
Okay, you're gonna say the letters. I'm gonna draw for you. So just say the letters.
C, 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 and O2.
And don't forget the double bond O.
Yeah, double bond.
Another O, say another O, and then the Na. Now, whatever this new guy is, Anu and everybody else, this guy's the salt lah. I hope that makes a lot of sense visually, right? Just look at it visually, it should make a lot of sense. Now, any question? We are done here. Okay, now your note should be a combination of, the previous week's note, which is,
Teacher, I'm not done writing.
oh, sorry. Go ahead.
Wait, why is the last C of the salt have 6 hands?
You are absolutely correct. Thank you very much. Oh, Caston is here. Yes, Matthew. Yes, Matthew, you are right, and I am wrong. How many hands should I remove? How many hands should I remove?
2.
Right. Thank you very much. Caston, I didn't see you just now. Caston, did you just come in? Correct.
Yeah.
Guys, I'm gonna have a conversation with Caston for a while. Caston is your senior in O level, right? So give us some time. Caston, tomorrow is it your MCQ?
I think it's like Friday, I think.
Do actually, I give all my students freedom whether they want to talk about MCQ or not lah. I do, but we should actually talk about it nearer to the exam. Sorry, I forgot to mention that. But in general, let me confirm, you are not very worried about your MCQ right now?
Just for chem only.
Let me confirm again, when is the chemistry MCQ?
I think Friday.
Okay. Does it make you feel better if you have tuition nearer to Friday? Not necessarily Thursday. Maybe Tuesday, maybe Wednesday, maybe Thursday lah. Does it help you?
Yeah.
Can you make a choice? Tuesday,
Wednesday.
I'll see you on Wednesday, and let's make it earlier, which is like 6. Would that be okay?
Okay.
Good job, Caston. I'll see you then. Bye. Yeah, that was your senior. And I hope everybody, by the time this time next year, you'll be as calm and as prepared as him. Right? Okay, any other question for this new one? So one more time, your note will be a combination between last week's note, which is more complicated, and this week's note, which should be simpler. I'm going to give you 5 minutes. You're going to use the tape function. Okay. Tape function just to help you memorize. Memorizing should be a very simple affair. Memorizing should be tape, tape this lah, tape this separately, whatever, tape this, tape everything. Tape separately, by the way, tape. If you want to tape separately, this, and this, that's fine. Tape. Now, before we start, to remind you, your eraser can be erasing tape only. Just to remind you, and it will make your life so much easier after you memorize. Undo again. Okay, I'll give you 5 minutes just to download everything in your mind using the tape function, please. Please do not stare at the reaction map and read it. Please don't do that. That's not a proper memorization technique. Please read tape and then just try. In fact, I'll give you 10 minutes, like that's more fair. Okay, start 10 minutes. I need 10 minutes. And after that, we're going to see some examples. Now, you need to do this. Why? You need to have a sense of how easy it is to memorize this. That is the point. If you feel that this is all too difficult and impossible, we have not achieved our goal. And that is a cause for a question. You need to ask me, hey, how come I'm having trouble downloading this in my mind? Okay, this was all designed to make it very easy to memorize. Okay, not all the details, I understand that, but most of them, please. If you need to see today's note, please tell me. I purposely close them so that you cannot see them. When you recall, you can recall by saying things. Most people don't like that. You can recall by writing on top of the tape. That is more recommended. I am so sorry. I need to remind you on one more thing. I am so sorry. I need to remind you on one more thing. When you are going to rewrite things here, for example, I'm supposed to write substitution. Remember to write down half-half substitution. Remember to write down half-half like that because it will make it much easier for you to erase. Okay, so sorry, I need to use a normal erase. If you do it on top of the original thing, it will be very hard for you to erase. Let me show this one more time. If I write down here, substitution, a very natural way, I will have a problem because I cannot erase it properly like that. That's bad. That will ruin your note. Okay. Please, if you don't understand what I just said, it's a good note thingy. Please tell me and I'll re-explain. Do not do in the middle of the thing. Do it on the half part of the thing. Easier to erase. Do not ruin your notes. We are halfway. If anybody feels it's very difficult to memorize this, please tell me right now, yeah? At this point, you should be around more than 50% into the memorizing, hopefully more, but definitely more than 50%. If you're struggling, please tell me. Yeah? Okay, for now, let's stop our memorization effort. I use thumbs up, okay? I need to do a quick survey. Who managed to recall, to write down, okay? More than 50% of the reaction map. Let me see some thumbs. Okay, right. Okay. Nicholas, Ariel, Joel.
Yes.
Okay, do some thumbs up. Ariel, Kirana. Oh, okay, okay, understand. Okay, so unless I'm wrong, the thumb keep disappearing. Unless I'm wrong, everybody did manage more than 50%. You should feel quite good about yourself. You should feel that this note is useful. You should feel that, hey, memorizing is not that hard. Who did more than 3/4, 75%? Okay, good. Okay, 1, 2, 3, sure, good. 4, 5. Oh, that's quite a lot. 5. Okay, who managed to recall everything at least once? So 100%. You will have your mistakes. I don't mean that you don't have mistakes. I mean that you make the full effort, you will of course have mistakes. Let's consider that a 100% effort, not result. Who managed to do that in 10 minutes? Okay, good. Okay, good for you that one person who are fast. Hey, you usually need 15 minutes. People, 15 minutes is what we are trying to do, recalling all these details one day before exam. Should be very helpful for you. Okay. Now, if there is no more questions, never mind the missing effort. It's okay. I just want you to have a feel that this is something useful, something you want to carry. Now, feel free to erase the tape and refer to the notes because I am going to look at some questions. Get your notes ready and look at my screen sharing. Again, one more time. Erase your tapes, please. Out. Eraser. Erase tape only. Very happy. Most of the time, you should erase your previous rewriting first. So if you can do that, that would be nice. If you're very confused, either ask me now or later. Okay, your note should be ready, right? Now I am showing you some exam questions, okay? Exam question. I'm so sorry, where is it? Exam question, where are you? Okay. You should realize by now that MCQs in science are in the order of the topic that you learn. So if you want to find organic chemistry question, it'll be in the last few questions. You have the total of 40 questions. Here's question 37. This is obviously an organic chemistry question, right? Let's just check out 36. Okay. Now, to be clear, I didn't cover all of organic chem. I cover most of the important thing. Now, can anybody venture a guess? Question 36. Question 35 is not, okay? Question 35 is not. Question 36. Is this organic chemistry or not? Somebody venture a guess. Okay, gonna ask somebody to guess already. Sun, guess.
Is it's not.
Right. And Sean, I understand, Sean and everybody else, this does not look like what we have covered. It does not look at all. Now, this is the introduction to organic chem because they will start with crude oil. Now, I intentionally leave this part out because that is the easiest part. Your teacher will cover them one. It's mostly memorization, it's mostly not understanding. My point is, OChem start with crude oil. We are studying crude oil, fractional distillation, whatever. This is the intro. It is not in your note. I purposely leave them out. You shall complete them by listening to your teacher. And therefore, for now, we skip this question. The rest are more important. Good guess, Sean. Totally understand. Okay. Now, 36 is OChem. 37. If you remember from last week, we are talking about isomers. I'm going to do a quick revision. Isomer is same, something, different, something. Rachel, what is isomer? Same what, different what? Rachel, you might be muted. Rachel, are you okay? Rachel. Let's try other people first. Ariel, same what, different what?
What?
For isomer, referring to last week. The isomer is same what,
Is that
different
the
what?
routine thing?
If you refer to your notes, okay, later refer to your notes again, is the same chemical formula, but it is different chemical structure. I'm sorry, they call it, don't call it chemical structure. They call it structural formula. Now let's put it in, I'm so sorry. Let's put it into words that we can understand. Structural formula. Chemical formula is your whatever, your C something, your H something, your O something. So the number of C, H, and O will be the same. But different structural formula, in some sense, it means different drawings. but there's an important feature to watch out. So I'm just going to use this question to revise your understanding on isomers. This is covered last week. We don't mention it much. I am telling you one question in the exam is isomer. They kind of give some respect and lip service to isomer. It's not lip service, just some respect to isomer. So one question on isomer, just one. Okay, it's a bigger thing in JC lah. So look at the chemical formula. The first thing we do is simply to ascertain that everybody's chemical formula is the same first lah. All right. So this is C5 and how many H? Eben?
Uh, 12.
Yeah. Well, guys, you basically count quickly, right? 3, 3, 6, right? 7, 8, 9, 10, 11, 12, right? Get used to counting quickly. Let's just make sure that everything else is also C5, H12 lah. Okay, you'll get your turn. Anu, C5H, number 2. Matthew, do this one. Okay, Nick, do this one. And then Vera will do this one. Anu, number 2, C5H. I think the mic got problem. Okay, try again, Anu.
12.
Okay, thank you. Matthew, also C5, H how many?
12.
Okay, thank you. Nicholas, C5, H.
Huh?
Number 4, C5, H.
C
Okay, quickly count it.
H 12.
Good. 3, 3, 3, 3. Okay, well, right. Last one, Vera, C5, H.
H12.
H12. Thank you. So we confirm that everybody have the same chemical formula lah. So it's a matter of different structure, which means this is a matter of our visual ability. How well we can see it. One more time, isomer is very visual. As far as I can tell, most of you are very strong visually. Let's make use of it. I'm going to erase everything else first. Okay, everything. I'm sorry, might as well just erase everything. I'm so sorry. So everything is C5H12. That's confirmed, right? Now, this is to revise what happened last week a bit. This will feel new, even though I have done it before. I'm gonna count. This is C number 1, C number 2, C number 3, C number 4, and C number 5. Okay. For some reason, I do that. And then in number 2, I'm gonna do the same thing. I'm going to count randomly. I'm going to start here, C1, C2, but I will not go to here, C3. I will not do so. I will go here, C number 3 and C number 4. Why? Because I'm supposed to find the longest path. The longest path is definitely 4, not 3. If anybody is confused right now, please tell me. So for number 1, the longest I can count is 1, 2, 3, 4, 5. For number 2, the longest I can count is 1, 2, 3, 4, and therefore I declare this not the main path, but the branch. There is a branch in number 2, which you do not see in number 1. This is not a branch. This is not a branch at all. You can see it many ways. A branch should have a feature like this. Hey, like that. Hey, I have a triple path. This is not a branch because there's only double path. That's not a branch at all. A branch must at least have triple path, or in this case, 4 path. That's definitely a branch. So not a branch and a branch. If this is not clear visually, please tell me. Now, number 3. I count here. Number 1, I start randomly. Number 1, number 2, number 3. I can go here number 4 or I can go here number 4. Both does not matter. I choose one. I just choose one. Therefore, this is obvious that this is a branch. Okay, it is obvious that it is a branch. Okay, now before continuing to 4 and 5. Number 1 and number 2 have different structural formula. They are isomers. One has a branch, one does not have a branch. Number 1 is equivalent to just a straight line like this. If you do not understand, at least take some notes. All of these isomer notes must be in writing. Is everybody clear? Number 1 and number 2 are isomers because they have different structure. One branches, one does not. Okay, at this point, I shouldn't rush. I do need to see some thumbs up. Can I see some thumbs up? Okay. Thank you. Now, here comes the shocker. Maybe it's a shocker, maybe it's not. Number 2 and number 3 are not isomers. I will give you the full reason. First of all, you can see that the branching is similar. There is one branch. So the branch is similar. So, thirdly, my numbering, the numbering is the address, right? My numbering should have been done something like this. I shouldn't have done number 3 like that. I should have done it the other way. Because there are always two ways of numbering, right? From one end or the other end. Why is my 1, 2, 3, 4 correct? Because my branch number is now number 2. If I count it 1, 2, 3, 4, my branch number is number 2. The previous way, branch number 3. Hey, which one should I choose? I should minimize the address of the branch. That is what I must always do. In naming situation, I must minimize the address number. If I have two options, I choose the one with the smallest address number. With that, I clearly demonstrate to myself the branch is in at address number 2. Branch address number 2, branch address number 2. This should eliminate any doubt. They are actually not different. They are actually the same thing. This is how your teacher will teach you. I'm just showing it to you first. There's a simpler way for next week. One more time. 1 and 2 are isomers. Number 2 and 3 are not isomers. They are exactly the same. Even though they don't look the same. They are exactly the same. Let's go slow. I need to see some thumbs up or I need to hear some questions here.
Yeah, but 4 and
4 is coming. 4 is coming. Definitely 4 is coming. Okay, we should at least finish 4. Should at least finish. Now, I'm going to go to 5 first. Okay, I'm going to go to 5 first. Why? I'm going to go straight to numbering 1, 2, not 3. That's wrong. Not the longest path. Number 3 and number 4. And as a conclusion, I'm going to invite somebody. Joel, what is the conclusion of number 5?
Oh, it's the same as 2 and 3.
Very good. All these are not isomers. They are exactly the same. Hopefully, you can see that visually. They look different. They are exactly the same. That's the training here. Now, for number 4, no matter how I count, I will end up as 1, 2, and I don't know, 3. Or I don't like this. I want to put this as 3. No, I don't like it. I want to put this as 3. Doesn't matter. No matter how I count, the longest path is 3. That already shows this is different. Just to eliminate any doubt, this is a double branch. 2 times branch at address number 2, no matter how I count. Okay, so this is clearly another isomer, which is different from the rest. Because the branching is different, the address is different, whatever. I will invite Matthew. Matthew, how many of the structure represents isomer of one another? The question is
Two.
weird, lah, yeah? So what do you think? Just make a guess.
2.
The answer is 3. But why? But why? Okay, here is one guy. Here is
Oh, I see it. No
2,
problem.
and here's 3. You understand, right? That's what
Yeah.
the question means. The question wording is very weird. Just
Okay.
answer 3 lah. Okay, how many isomers are here? 3, something like that. Okay. Okay, the 3 does not refer to this 3. No. The 3 refers to the 3 different things. Okay, we're going to go for a break. Let me see some thumbs up, or let me see some questions. Is this question okay or not? Wait. Okay.
So
Yes, Nicholas, if you are done, feel free. I will see you on Wednesday.
okay.
The rest, take a
Bye.
break for 5 minutes.
Bye-bye.
Please make full use. Bye-bye, Nicholas. Make full use of your break. Okay, let's do a mic test one more time, yeah, just to check if everybody's here. Anu, can you hear me? Okay, Anu and Ariel, you are here, yeah. Ariel, just do a middle check. Is this too fast or too heavy? What do you think?
Sir.
It's all right, thank you, Ariel. Eben, can you hear me? Okay, Joel.
Yeah.
All right, got it. Kirana Rachel. Okay, Rachel. That's why. Rachel, can you just confirm you can hear me clearly? Maybe you can type in the chat, yeah. Okay, so just now when I was asking you and you didn't answer, is it because of the mic issue? Just type. Okay, understand. Then for now, Rachel, make sure you can follow, and if you want to attract my attention, maybe do a typing or something. Okay, for now, please do that. Don't be left behind. Okay. Okay. Sean, Vera, can you hear me?
Yes.
Okay. Matthew and Kirana, sorry.
Yeah.
Okay, wonderful.
Yes.
Okay. Kirana, is this followable, so to say?
Yeah, like okay.
Good. The last question, definitely something deep. It's okay. Don't mind that. Okay. Now, a small announcement. For those of you who are doing combined chemistry, do not be afraid. Doing this with us will make you feel very confident. By the way, the syllabus is not very different. The question in the exam is different. So you have to cover the same syllabus anyway for combined or chem student. But the question, you'll experience something slightly harder, and do not be afraid. We're doing this together, ma. Okay, again, the purpose is to give you stability and confidence. Okay, you will get that. For those doing, IT program, when your teacher will, just anyhow do more, right? Because they can. Do this question with us first, and then we can transition to the harder ones from your school. Okay, this will not be a waste lah. For the rest of O level, this will be what we do. Now, I want to show you just a survey, people, just a survey. I want to show you what kind of question they ask, and therefore make you understand they are not asking too many things. Okay, I established to you that they will first ask you something about the introduction, the crude oil thingy. You don't understand this, totally fine, the easiest part. We'll see in the next paper whether this will come out again. I am also telling you that they like to ask one question about isomers. This is an example of isomer question. So 1 and 1. What's the next? Okay. Blah, 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 blah. I'll tell you straight, yeah. This looks very different. You don't know what this is going on, but I'll highlight one thing. In your reaction map, okay, the one that we did today, there is a hydrogen gas, isn't it? There is a hydrogen gas. Now I'm going to invite somebody to tell us hydrogen gas is needed to change from who to who. Please look at your notes, okay? Please look at your notes. Matthew, hydrogen gas exists in your reaction map. Where is it?
Changes butene into butane.
Good. And by the way, it's also produced in cracking, which is the reverse reaction from butane to butene, correct? Matthew?
Yes.
Good. Which means that's a very big clue for this question. Let me tell you why this question looks very unfamiliar, because it's application. He's mentioning something that we never write note before. Ayo, don't worry lah. This is application. Don't worry. You have hydrogen gas as your clue. Okay, we're not going to answer this question. I'm just telling you this is reaction map, one of the reaction, but disguised because it's an application question. You shouldn't focus too much on the vegetable oil. You should focus more on the hydrogen gas. Next week, when we do this. This week, we're not going to do this. Just a survey, All right, now 39. Please look at your reaction map. Your reaction map will contain a lot of water. A lot of water. Okay, more than 2. Okay, I'm gonna invite Eben. Combustion of fossil fuel. Is it in the reaction map or not?
Combustion.
Yeah, combustion.
Combustion is,
The middle one, correct?
yeah,
Everybody, the middle one. And does it produce water?
it does.
It does. Okay, I have one water here. Okay, water. Okay, so this is correct, and we're looking for not a product, right? Esterification, we're gonna cover soon. We're gonna ignore that for now, like this. Fermentation of glucose. Okay, first thing first, let's confirm. Vera, fermentation of glucose, does it exist in the reaction map?
No.
It does, but that's because glucose is the term for sugar. It's a biological term. It's a biology term. A bit unfair for the chemistry and physics student, but you biology students should know by the end of Sec 4. Now, guys, complete your note. Everybody say that sugar is glucose, glucose is sugar. Put the word glucose in your reaction map, and then please put a thumbs up. We're upgrading our notes based on the question. That's what we need to do. Okay, good. Thumbs up, good. Glucose is sugar, sugar is glucose. Now, officially, this is in the reaction map. Back to you, Vera. Does your reaction map say fermentation of sugar produces water?
No, it doesn't.
It doesn't, but a bit uncertain. Here's your fermentation. Here's your fermentation, just to confirm to everybody else. The problem is your reaction map also say you do not know the reaction. So that kind of bothers you a bit. I will now confirm immediately there is no water fermentation. There is no water. Okay, because your reaction map, I specifically say you do not know the reaction. Okay, now what do you do with this new information? You should add it to your reaction map. It does not produce H2O. Why are you doing this? You're upgrading your note through real questions. Please do so and thumbs up. And okay, can I see a bit more thumbs up, please? Okay. Okay. Your reaction map is not complete. You have to fill in with details for the exam. Okay, that's what we need to do. Now, last one, neutralization between this and that. I'm going to invite Kirana. Kirana, can you confirm, does the part D exist in the reaction map or not?
Yes.
Where is it? Which part?
Is it the vinegar?
So what you mean is acid plus base, correct?
Yeah.
But it is true that this is acid and this is true that an alkali or base. However, he specifically say this is hydrochloric acid. Please confirm the acid here is not hydrochloric acid. Confirm? And the alkali here, it can be aqueous ammonia, it can be anything, so that's fine. The problem is that this is not HCl. So strictly speaking, Kirana, this reaction is not in the reaction map. However, obviously, this is also neutralization, right? Obviously, correct or not, Kirana?
Yeah.
So therefore, even though this is not in the reaction map, you should kind of know does neutralization produces water or not? What do you think, Kirana? This is from Sec 3.
Yeah.
It does. Yes. So therefore, by the way, everybody should know already the answer is C. Okay. Now this question is a classic example of they test you on so many reactions. It's classic. Reaction map should help. You shouldn't feel lost, except for part B, which we're going to do very soon. Okay. One more time. I am telling you, the MCQ will contain one introduction, one isomer, one application question, which means reaction, by the way. They just hide it kind of nicely. And one like full-blown reaction test. Every option is a reaction. I hope you are not feeling lost. And last one, polymer. Polymer is something we're going to cover right now. We're going to cover this guy and polymerization. Okay. Okay. Now, we're going to start by looking at this question, even though we do not know polymerization. Look at your notes one more time. Your notes also contain everybody which should exist in the, in this question. Please take note. Who is this guy? Okay. I'm having trouble tracking. Sơn, who is this guy?
The carboxylic acid.
Correct. However, you pronounce it carboxylic. You are correct.
Oh,
It's a
okay.
carboxylic acid. Please note, Sơn and everybody else, this some reason is a double carboxylic. And that's totally fine. It's totally fine. It's okay to be a double carboxylic. I'm gonna ask one more carboxylic. Where is it? Option 1, 2, 3, 4. Rachel, option 1, 2, 3, 4. Just chat. Just chat. One more carboxylic, please. Rachel, if you can hear me, at least type. Okay, yeah. Is it in 2? Yes, correct, Rachel. There you go. That's number 2. Yes, your carboxylic. How do we identify carboxylic? Visually. Your visualization is very important. And it's also easy by right. Okay, this is the number 4 guy, right, in the reaction map. Oh, the carboxylic guy. Okay, now let's identify the alcohol. Ariel, tell us, where can you see alcohol? Option 1, 2, 3, 4.
Um, 3 and 2.
Yes, alcohol is OH, people. Not this OH. This OH is not alcohol. That is not alcohol, but this is alcohol. This is also alcohol. Is that what you meant, Ariel?
Yes.
Thank you very much. Okay, let's identify the double bond, the butene and what sort. Joel, please identify our double bonds for us.
Double bond.
Yeah,
Is it?
which one? Which option, basically? Your butene, contains a double bond.
Is it option 1?
Yeah, option number 1, double bond between 2 C's. Anybody else contains this guy?
Also option 4.
Yeah, thank you. To clarify, thank you, Joel. To clarify, this is not what we meant as a double bond because it actually meant C double bond. That is the butene family, so to speak, the alkene family. The C double bond O belongs to the carboxylic acid. So more appropriately, C double bond is our identification. Okay. Anu, there's one new guy in the block. Who is it? Which one? Your mic?
And
Take up. There. This is the new guy. And let's call it Amin. It's a new guy. It's a latecomer, but this guy simply follows the rule. 1 is H, 2 is O, 3 is N, right? 4 is C. Anu, confirm for us. This guy is happy. This guy is okay.
yeah.
Good. Why? Because N is supposed to have 3 hands. There you go. Happy lah. We're not going to answer this question. This is a revision for what we have done. Okay. And then I'm going to carry on to polymerization. Any questions so far? Okay, good. Now, let's go back to your notes. We're going to write things down already. All right. Watch my screen and write notes. Okay. Just a minute. Now, first, I must teach you a new reaction. The new reaction is easy. Just put this in a new page for now. For now, new page, please. Okay, new page, please. Okay, I introduce you something new. It's a box. It's a box, and then I'm gonna put OH here. OH is the alcohol, right? Now, the box means it can be anything I want. Okay, blah, blah. They put it as a black box. One more time. The box means just put anything you like. Right now, I'm not too concerned about what is inside the box. I am concerned what is outside the box. The guy inside the box doesn't matter. It's there. That's what the box means. You will see this box a lot in exams, and that's where the way of saying there's something there. Don't care. Just the OH matters for now. Okay. I have another box, and that box is shaded differently to indicate that I don't know what's inside, but it's different from the first guy. Okay. I still don't know what's inside, and it doesn't matter. And you will see that I have my carboxylic acid here aimed at each other. Okay, I have one carboxylic N, I have one alcohol N. And now I'm going to do my reaction. The reaction is very simple. I'm going to cut and cut. Then this will produce H2O. As a result, because I cut away the H and the OH, I have a dangling O. There, it dangles. Here's the other box. Still the same thing. We don't care what's inside. I have a dangling hand also. I have two dangling hands. I need a thumbs up here. The dangling hands are the most important thing right now. Do you understand that we have two dangling hands right now? Thumbs up, please, or ask questions. Okay, okay, right, okay. Anu Ariel Eben, okay ya? Okay. Now, two dangling hands means they're unhappy, right? O has a dangling hand. He is unhappy. C has a dangling hand. He is unhappy. Whatever can we do? Well, join hands lah. Join hands. Make you happy. Call this now ester bond. They're very specific here. They want you to identify this as an ester bond. Ester bond is the holding hand between this dangling O and this dangling CO. Ester bond. This new guy is called ester. We have a new reaction, a reaction between alcohol and carboxylic acid. And it produces something new called an ester by all this method. Ester bond, ester, esterification. This is not yet polymerization, but this is the basic. Please write this down. You need this as your note. I'll give you around 1 minute. If you have any question, now is a good time to ask. Okay, I'm going to continue here. Now, let's practice our good notes a little bit. Let's reorganize. What do I mean? I'm going to put this down and I'm going to put this up because I realize there's a better way. Well, how to do that, right? How to do that indeed. Okay, there are a few ways to do it. First, I'll take the opportunity to make this a bit smaller and then I'm just going to move it there, right? Then I am going to take this other guy. Okay, move it up first and then use the opportunity to make it a bit smaller also. Just a practice for your. Then I'm gonna say, just to make it clear to yourself, this becomes that. We call that esterific. I'm sorry. Let's just use a pink color. You can use whatever color you want. Just be consistent. This is esterification, which produces an ester bond, and we call the end product ester. Okay. I hope you can reorganize this quite fast. Now, the reason why is because I'm going to do something else here, right? Okay. Now, please follow me right as I write. I am going to introduce something else. Okay. It may have a different box. See, different shading. And this new guy. Ah, wow. This new guy is coming in. This is the amine, right? This is the new guy, amine. Okay. I have the same carboxylic acid here. Top, carboxylic, same thing. Okay, I have the C, I have the double bond O, okay, and I have the OH. A very similar thing happened. Remember, a very similar thing happened. Take one H, take the OH, cut, eject H2O, and now we have a dangling guy. I'm so sorry, that's bad. You have your N, you have your H, and you have a dangling N. You have your C, you have your double bond O, and you have a dangling hand, right? Eben, what will happen to these two dangling hands?
They form the
They form a bond, clear?
yeah.
And you don't call this the ester bond, you call this the amide bond. Now, for those from biology, again, there's a very strong, there's a very nice intersection with biology for a while already. I'm just telling you one of them. This is your amidification. Whatever that is, you produce something called an amide, you know, and the amide contains an amide bond. They're very particular with all that. And this is part of your protein structure. You will discuss this in protein biology students. In fact, you'll be discussing something more complicated than this. Good for you lah, good for your chemistry. It's nice being a bio student sometimes. For the physics student, doesn't matter. As long as you understand this, you'll be perfectly fine. Okay, there, I have shown you two reactions which are very similar to each other. That's my point. Esterification and amidification. We need this for the polymer chapter. I'll give you 1 minute to finish everything because we need this. Okay, then I'll move. Questions, please, if you are not sure.
Wait, why did you draw like the arrow pointing up for esterification?
All right, so just to be clear, good question, Ariel. I reorganized just now, and I want to mention that we start here, and we end here. Make sense?
Oh,
We start here. Okay. This one is another start. I'm compelling the start. That's why I'm doing it that way. The start are very similar. The reaction are very similar. The end product is also rather similar. Okay.
Okay.
That's just how I write notes. You can rewrite it else somehow another way. Okay. Anybody else have any questions? Okay, good. We're going to keep this in mind, and we're going to use this for our polymerization. The polymerization starts now. It's a big chapter. They like this a lot, and it is also not very difficult. It's really not difficult. Nothing much is difficult. Okay. Okay, I don't think we'll be able to cover questions today, but at least we can cover it next week, and then hopefully you'll be very happy. Now, I'll stop the screen sharing just for a while. Okay? On my video. Okay. Just now, I present to you two guys. Okay, one here. My hand is here, not free, which represents my hand not dangling. The other hand is dangling. Okay, the other hand is dangling. And this hand needs to hold somebody else. But this hand is okay. And then what happened? What happened is I have another guy. I have another guy here. And the other guy is quite happy here, but have another hand like that. And so therefore, they join hand. That's your ester bond, or that's your amide bond. I am alcohol. The other guy is carboxylic. Let's join hand because both of us have dangling hands. One more time. I am amine, the new guy. I have a dangling hand because of the H2O thingy. And then the other guy here is carboxylic. I have a dangling hand. Let's join hand together and be happy. Let's make a new thing. That's what happened. Now, in polymerization, is very simple. Polymer is very simple. Very, very simple. It's a stupidly long thing. It's a string, basically. It's a string. I am currently not a string. I am holding hand with another guy. I am holding hand with another guy. That doesn't make me very long. It's just one hand with one hand. Oh, I'm not double the length. That's not long. How to make something very long, a polymer? It's so simple. I must have two free hands. Two. Not one. Not one. Two. Why? Because I can grab somebody here. I can grab somebody here. The guy next to me, guy next to me can do the same. I have two free hands. I grab you, I grab you. The guy next to me can do the same thing. One hand, and we just repeat that. What is the condition of being a polymer? It's so simple. I have two free hands. I have two dangling hands. Join, 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 join. I become very long. Simple, right? Not one, but two free hands, two dangling hands. And that's what I'm going to show you right now. Okay, now everybody, you should be seeing my screen, yeah? One more time, two dangling hands, okay? I have a box. The box doesn't matter. I'll label it A. What is in A doesn't matter. What matters is what is sticking outside the box, which is an alcohol. Oh, how convenient. I have double alcohol. How convenient. I have another box called B. It doesn't matter what is in the box. What matters is what is outside the box. I have a carboxylic acid. Oh, how convenient. I have double carboxylic acid. Because of the esterification reaction I told you just now, which is basically eject H2O, right? I'm sorry, I should have used pink. Never mind. Let me use pink. Okay, eject H2O. Okay. Hey, that means something the same happens here, right? Something the same happens here. Something the same happens here. Everything is, being esterified. What happened? I have a dangling O. I have a dangling O, right? I have a dangling this guy. This is just what I wrote in the previous note. This is just what you wrote just now. But the difference is I now have left and right. What happened? Chup, ester bond. Right? Ester bond. Chup, ester bond. Same thing. Hup, ester bond. I didn't draw it full, but I hope you can imagine it. Okay? Ester bond, ester bond, ester bond, ester bond, ester bond. Hup, hup, hup. What did I do? I put a big bracket. Put another big bracket. I purposely let the dangling hand cross. I told you that dangling hands are very important. It crosses. This is a formal presentation. And I put the letter N here to represent something very big. For your information, this is around 1,000 to 5,000. What does that mean? I am repeating this process 1,000 to 5,000 times. It becomes very long. This is your first drawing or viewing of polymerization. One more time. Start with double alcohol, double carboxylate, do the same reaction, but now I notice they are left and right dangling hands, and therefore they keep connecting. I do not want to draw something very long. I just draw 1O, 1B, dangling hands, bracket, bracket, and to represent that is very long. The 1,000 to 5,000 is FYI only. This is a polymer, something very long. That's it. Formed by short things left and right. Draw or ask question, please. Draw or ask question. 1 minute. Joel, can I confirm? Is this okay?
Yeah.
Okay. Ariel, is this okay?
Yeah.
Okay. Rachel, you can type, is this okay? All right, okay, thank you. Okay, shouldn't take long, right? Okay, let's just call this guy monomer. Monomer versus polymer. Monomer, mono one, so one guy, I suppose. Monomer A, and let's call this monomer B, not polymer, monomer B. They have fulfilled the requirement of forming a polymer. What's the requirement? Left and right dangling hand. That's all, right? Left and right dangling hand. Forming a polymer AB, 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 whatever. AB, 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 AB. Yeah, something like that. Okay, should be quite easy to see visually. Now I'm giving you another option. I have a different monomer C here. Monomer C. I have an alcohol here. The box doesn't matter. I have a slightly different thing. I have a carboxylic acid here. Okay. And just to be clear, I am drawing the exact same monomer C. They are the same. They are not different. They're still monomer C. I'll do that. C, OH, CO. After a while, you should be drawing this very fast. And what do? I can still do the chop, 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 chop. Okay, H2O. Okay, this ejects H2O. And as a result, I have a dangling, blah, 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 drawing the same thing. C, dangling, O, okay, O, dangling, O, dangling, C, C, O. You should be drawing all this. And Kirana, just venture a guess. What happens to this dangling hand and this dangling hand?
Ester bond.
They just form an ester bond to make them happy. Will something the same happen here?
Yeah.
Yes, because, they have another guy there, ester bond. And also here, can you agree that is also an ester bond?
Yeah.
Okay, so to finish the polymer, what do you do, Kirana? Double big bracket crossing the dangling hand with an N. That's your polymer. From monomer C, just one type, many monomer C, but one type. You have polymer C, 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 C. Okay.
Okay.
Nothing wrong with forming a polymer with one monomer. Nothing wrong with forming a polymer with two monomer. What I'm telling you is outside the syllabus right now. If you have different monomer, you can give the polymer different strength. A polymer is just plastic, okay? The plastic that you know. A polymer is plastic. If you have different monomers, the A can give it an important feature. Maybe the A can give it I don't know. I want my polymer to stretch. Maybe A is stretch. Maybe B is fire resistant. So I have a stretchy polymer which is fire resistant. Polymer A and B. Polymer C is easier to make. I just need to have one monomer, but also I only have one superpower, something like that. Nothing wrong with polymer AB. Nothing wrong with polymer CC. Really, nothing wrong. I'm showing you the two options. Okay. I am going to continue. If you are not done with your note, please tell me right now. I will stop. Okay, I will now demonstrate another polymer with more than one monomer, right? Just one more. Okay, I'm going to call this polymer D, and I'm going to give it a very different end. Hey, the new guy. Double amine. Hey, double amine. Reusing polymer B, double carboxylic, and you should remember this from the previous, right? You should remember this from the previous thing, right? What do you do? Cut, block, H2O, eject. You have now a dangling D with an dangling H and dangling H. You have your B, which also dangles, CO dangling, CO, I'm so sorry, that's bad. Dangling. Oh, what do you do? Amidify, amide bond, amide bond. Do this a few times, you're ready for exam already. Huh? Big bracket, make sure you cross and then put N. Okay, it's similar to AB. This is now DB. Okay, sorry, I gotta give a very clear cut here. Okay, give you 1 minute. This is very similar to AB. This is now your DB. I'm telling you, there are more than one way to make polymer. There are actually around maybe a few millions plastic right now, a few millions polymer. No surprise, we're learning more than one way to make a polymer. Okay, no surprise at all. When you're lacking in space, move things around, reorganize things. Okay, make it nice for yourself. Okay. Now, I need to clarify something before I give you the last example. I need to clarify, not all dangling hands can hold hands. So for example, I have the A here, which is a double alcohol, and I've already made it dangling, okay? It's already dangling here. I have another A, which is of course a double alcohol, so I have another dangling hand. They cannot hold hands. Okay, alcohol don't react with each other. It's not that easy. The dangling hand is there, but they don't react. How do we know? Well, that's what the reaction map is for. Most of the time, if the reaction map does not contain this, it doesn't work. Your reaction map is currently I'm so sorry, where is it? I'm so sorry, your big C plus the two polymer reaction. There isn't a lot. The big C plus ester and amide. So can two alcohol reacts? To be fair, you don't know, but you will say, but I never see in the reaction map, so I shouldn't assume they can react. I shouldn't assume. I should assume that they cannot react. That is the function of your reaction map, to tell you what is possible, and therefore everything else is not. Okay, something like that. Something like that. Okay, give you another example. I have a double carboxylic. I already made it dangling. Okay, I have two dangling hands here very nicely, left and right. Okay, inviting Matthew. Matthew, can this react or not? Matthew, are you okay? Matthew, are you with us? Sorry.
No.
But how do you know?
Like it's not in the
Reaction.
map.
That's it. That's it. It's not that you know. It's not that I know. But it's not in the reaction map, so no reaction. Okay. Hopefully this is clear. If you want to write this down, go ahead. Okay. Not every dangling hand can react. Okay. Not every dangling hand can react. Just put it on one side there. Yes, that's enough. Now, final thing to introduce today. Okay, I think we have fun. I am going to do an example on one monomer, but I'm going to give you something very different. Okay, I'm going to give you this. Now, everybody should know who is this guy. Again, we always should do a check lah. Eben, is this correct or not?
Yeah.
No, there are
Wait.
two mistakes. Spot it.
What?
There are two mistakes in this guy.
Oh, yeah.
Okay, say first C, second C, third C. What's the problem? Hey, Evan. The first C count. How many hands?
There's too many hands.
Okay, how many should I remove?
Just one.
Okay, I'll say I remove one. Oh, sorry. Okay, I remove this one. Second C, okay?
No.
Okay.
No,
remove
too
how
many
hands?
as well.
Yeah, to remove how many hands?
That's one as well.
Okay. The last one?
One should be fine.
Okay, thank you very much. Hopefully everybody can see. Remember the rule, 1H, 2O, 3N, 4C. They always check, right? We'll call this pro one address ini. The Na, the double bond C is in address number 1, propene. Now, I'm claiming to you that propene can be a polymer also. Remember, in the end, polymer must have two dangling hands, one on the left and one on the right. And the reaction must be valid lah. Then they can hold hands. So, I am focusing on the double bond. The double bond is always the focus. I'm going to put a color, different color to one of the double bonds, just one. Okay. And then I'm going to say to myself, hey, I'm going to use this double bond to make a dangling left and a dangling right. If I want to do that, I have to make sure my left-hand side is empty, which is not. Left-hand side is not empty. My right-hand side is also not empty. They are both not empty. I'm going to do some rearrangement. Free rearrangement. No permission needed. Free rearrangement. What kind of rearrangement will I do? I'm going to label this C1, C2, C3 so that we can follow, right? I'm going to make it bigger also. Sorry about that. Okay. Okay, how's my free arrangement going on? I am going to rearrange this guy, this particular guy, and move it here. This guy only. And then I'm going to take this guy and move it there. I'm going to do two free rearrangements. Two free rearrangements. What happened is that here's my first C label 1, like that. And I have rearranged it here. Yeah. I'm gonna make it blue just to make sure that that's my first rearrangement. My double bond, one orange, one normal. My second C, like that. And then rearranging it here. I am rearrangement is free. Please do that anytime you want. Rearrangement is useful in isomer and in polymerization. In isomer, we can rearrange if you know how to, no problem. Now, this one needs a thumbs up or a question. Do you understand the rearrangement? I didn't change the thing. I am just rearranging. They are still the same thing. They just look a bit different. Okay, I see some thumbs up. Either thumbs up or ask your question.
Yeah, I have a question.
Yes, Evan.
Like, what's the use?
Coming. So one more time, we're in polymerization. I want a dangling hand to the left and dangling hand to the right. I am freeing the space on the left and on the right by rearranging. You see? So empty, see? So nice. Empty, right? Empty.
Oh,
What do I do?
okay,
Very
okay.
simple, very simple. Break this guy. Hey, when we say break the double bond, break one of the double bond, not both. Just break one. Break it. And then rearrange the left and to the right. Okay, rearrange the left and to the right. So what will happen? So this one is break one of the double bond and rearrange, right? And rearrange again. We are rearranging a lot today. Rearrange. So what will happen? First C, second C, right? C, second C. Now a single bond. Now dangling hand, right? Because of the break. This one stays normal, this one stays normal. All the blue from the first rearrangement, I just draw it with blue again. 1, 2, 3. Okay. Hey, what's the point? A very good question from Eben. What's the point? Hey, I have a dangling hand to the left and to the right. And this dangling hand will be able to combine with himself. They will be able to combine with himself. So what do I do? Do that. Just let's make it a bit smaller, just easier to follow, right? And then I'm gonna copy. How do I copy? Just pop, boom. And how am I supposed to copy? I cannot copy. Wait. I have no idea how to copy. Oh, wait, I do. Copy, right? Copy and paste. Okay, just copying two, and they will combine. They will not. I am so sorry. Okay. Now they will combine. Pop up. Arrow, and this is just the normal addition reaction. This is from the previous node. Something new, addition reaction. They call it. The point is you have a left and right, which can form a polymer. Now we have a polymer. Okay, is this clear? Clear, thumbs up. If not, please ask your questions. Okay, let's complete this node in 1 minute. Thank you. Okay, in 30 seconds, we'll look at maybe one question, and then I believe we'll be quite happy to end.
Sure.
Yes, Anu.
What bond is this?
Oh, no special name because when a double bond breaks and combines, they call it addition reaction. It is from the previous reaction map. They call it addition reaction. Yeah, don't consider this something new. Consider this every time a double bond breaks and combines, they call it addition. It doesn't make a lot of sense here. They still call it addition. Have I answered your question? Anu, have I answered your question?
Yeah.
Okay. Okay. Okay, ladies and gentlemen, we are at the end of the formal notes. Your notes is not complete just because your notes should be completed by doing questions. I have no space, no problem. Good notes can rearrange one. In that sense, I do recommend good notes. We have 2 minutes. Wow, okay. Let's look at one question. At the very least, you can understand the question. It's a promise, okay? Oh, wow. Hey, wait, that's the exact thing. Oops. Oops, I actually did. Okay. Right. So, please confirm that this guy is exactly what I draw just now. Oops.
Yeah.
And is it a surprise that this is an addition polymerization question? Surprise or not?
No.
Okay, how do you draw the structure of polymer X? Guys, we are repeating this, okay? Guys, must rearrange. Must rearrange, okay? Look, I'm rearranging. Must rearrange, okay? Like that, like that, like that, like that. There's your H, there's your H. Hup. Okay. I have another H here, a H, H, H. You must rearrange. Here's the double bond, break it, hop, hop, dangling hand, hop, hop, and that's for 1 mark. If you understand, thumbs up, please.
Wait, in exam, do you have to cancel the double bond to show that you break
No,
it?
I'm showing the working. I'm just showing the working. You don't have to draw the double bond. You don't have to cancel it. You just don't draw it. But right now, I'm doing it for clarity purposes. Make sense?
Okay, can.
If you do it like that in exam, no penalty. Again, no penalty. So for some reason, people don't understand addition polymerization until the end. Please don't do that. It's one of the easiest thing ever, right? One of the easiest thing ever. Okay, so I have confirmed to you. I'm sorry, I accidentally used propene. Propene is a very common example of the addition polymerization. The question not very creative. I've shown you that you can understand this question. Now, look at question A. I challenge you, anybody, brave soul, do you understand this question and what might this refer to if you understand? Count the last question of the day. Any brave soul, please volunteer.
Is it just like moles? Like, wait, you mean A, right?
Oh, yes, yes. A is definitely a mole question, but I want more than that. Definitely more. Definitely more. I want more than that. What is this referring to?
Is this like bromination?
Bromination in the reaction map. Okay, where is it? Matthew, please tell me. In the reaction map looks like that. Where is it?
Top left.
Top left, whatever. And which arrow we're talking about? Going in or going out?
Going out.
Going out. Very good. This is your plus Br2 with a supposedly here a butene, right? But butene and propene cannot, right? The alkene family. Good job, Matthew. Anybody else realize that this is just from your reaction map? Together with your reaction map and what Ariel said, this is a mole question. You should be able to do this question. We don't have time today, but what I'm trying to say is you understand prelim questions. Okay? The last one, part C, you will also understand by next week. Now, okay. Any question before we end? Okay. Now, hopefully, ladies and gentlemen, for the Wednesday you can attend, we are going to do the same thing for AMath. Okay. Our goal is in 3 sessions. That means together with next week, we're going to complete this big chunk of topics. OChem for chemistry, AMath, the calculus, so to speak, and you will already experience some exam questions. That is how much we should cover, makes you very happy in Sec 4. For those who are missing Wednesday, please come in Thursday and do the AMath, right? If there is nothing else, let's take a break, enjoy. Kirana, would you just stay with me for a while? Okay. Everybody else, hopefully I'll see you on Wednesday. Bye.
Thank you.
Okay, Ariel,
Thank you.
welcome. Thank you. Welcome, Eben.
Thank you.
Thank you.
Okay,
Bye.
yes, okay, bye-bye.
Yeah.
Oh, bye-bye.
Teacher,
Yes, Anu.
what's the difference between ester bond and the amide bond?
The only difference is the one that's making it, right? So one is alcohol and carboxylic, the other is amine, the new guy, and carboxylic. Therefore, the result is slightly different. Does that make any sense? Therefore, drawing the bond itself, we require to draw something different, you know, C and O or C and N, if that makes some sense.
Yeah.
They are different visually, okay? It should be seen that way. Good question. Anything else?
Thank you.
Okay. All right. Kirana, can you hear?
Yeah.
Oh, oops, my bad. Oops. Okay, wait. Let me wait. Let me just stop sharing. Okay, I'll mic you. Okay, how are you, Kirana?
Good.
Good. How's your plans going for a holiday? You have a lot of plans, ma? Are they going well?
Yeah.
Okay, good to know. Now, not to waste your time, my question is very simple. Have you decided what to do with A math? You know, going into Sec 4.
I think I'm still gonna take it.
Okay. Then, as we move along the A math, follow it closely. In Sec 3, you experience an up and a down, right? Your A math was good. And then as we approach the end of year, it becomes very difficult to maintain A math. Let me confirm this. It's not just the end of year which is the problem. Before end of year, you already feel it is very heavy to maintain A math. Correct or not?
Yeah.
The main reason right now is because you must understand this. The main reason is not because you're not diligent. You're a very diligent student. The main reason is elsewhere. You have one extra subject called CCA handball. Okay. Practically, that is your most important subject. And frankly speaking, you score very well and you're very happy with it. Now, you should know your CCA is going to be very heavy until Thursday because I think you're a senior and you're influential senior. They will ask you to, do your CCA up to the N1 until you hand over. Correct or not? So you still have that CCA handball, and I want you to complete it without regrets. I want you to be very happy and satisfied with it. Okay? But AMAT is not going to slow down. AMAT is going to get harder. EMAT is going to slow down a bit. They have 3 hard topics, and then that's it. The EMAT is nice. AMAT is not going to play nice. Please manage your time well. Do your AMAT right now, so that your Sec 4 is better if that's your decision. That's all I'm trying to say. Okay? Okay. Don't miss the AMAT, especially when we finish the syllabus and then we go to the questions. You don't want to miss the notes when we go through the question. You don't want it. Okay? Try to attend it. Try not to rely on recording too much because if it is a real thing, you can still ask questions. Okay, Kirana?
Yeah.
Okay. Now, may I ask though, why do you want to maintain AMAT?
I mean, it's just an extra subject, so
Are
like
you sure you're not underestimating AMAT?
I just try AMF again.
But that's what I expect from you, right? Okay then. I'll see you on Wednesday, okay? Bye,
Yeah.
Kirana.
Bye bye.